Hey guys, welcome back. We are going to continue with chapter 5, moving into lesson 5.6. Lesson 5.6 is proving triangles congruent with two new methods using either angle side angle or angle angle side. Okay, so I am going to present my screen so we can get started. Okay, so for this lesson, before we begin, just up top, let's kind of do a quick recap of what we know so far. We've been talking about triangle congruency. We've been talking about corresponding pieces of congruent triangles. And so far, ignore that. So far, we know that we can prove triangles congruent by side, angle, side, right? When we have two sides in the included angle, by side, 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 and by HL. Okay, so these are the ones we already know. We're going to add two more to our list of ways to prove triangles congruent. And the first is angle side angle, ASA. Okay, and just like with the other theorems that we've learned so far, the order of the letters and where the A's are compared to the S is very important. So here we have two angles, such as angle C and angle F are congruent to each other, and angle A and angle D are congruent to each other, and the included side, the side kind of in between those two angles, the side connecting those two angles, the side that the angles have in common, okay? So it's angle, side, angle, angle, side, angle, all right? So it says if two angles and the included side of one triangle are congruent to two angles and the included side of the other triangle, then the triangles are congruent. All right, so that's angle, side, angle. Next we have, move down, angle, angle, side. Okay, so again, it's going to be two angles and a side, but we're not talking about the included side this time. So it's a non-included side. So we have angle, angle, side, angle, angle, side. So it says if two angles and a non-included side of one triangle are congruent to two angles, and the corresponding non-included side of the second triangle, then the triangles are congruent. All right. Now, it didn't have to be this side that was marked congruent. If they had chosen to mark this one congruent instead, I'd still have angle, angle, side, angle, angle, side. So you have options here. Okay. All right. So let's jump right into the practice problems to make sure we understand the two theorems. Okay, in exercises 1 through 4, it says, decide whether enough information is given to prove the triangles are congruent. If so, state the theorem you would use. All right, so we're looking at triangle GHK and triangle JKH. So based on the markings we have so far, I have that angle G is congruent to angle J. I have that angle K is congruent to angle H. And I have that side HG is congruent to side KJ. All right, so I do have two angles and a side, two angles and a side, and the side is the non-included side. It's not the side in between the two angles. So I have angle, angle, side, angle, angle, side. All right, so we're going to say that triangle, let me erase so I make sure I name this correctly. So triangle GHK is congruent to triangle. Make sure you match up the corresponding pieces. So it's going to be J, because that matches up with G. Then what matches up with this H? It would be this K over here. And then what matches up with this K here? This H there. All right, so JKH by angle, angle, side. Now, technically, you could mark this reflexive piece, right? This side is congruent to itself, all right? And you also could mark, using the third angle theorem, you could mark this angle equal to that one, So after making those new markings, and we can justify making those markings, right? I said the third angle theorem is what allows me to mark those angles congruent, the reflexive piece. So once you do that, you can actually say the two triangles are congruent by side, side pointed to the wrong thing, side, angle, side, right? Side, angle, side. Or you could use angle, side, angle, angle, side, angle. So based on whatever markings you list, there might be other options, but just simply based on the markings that were given, this would be the answer. Okay. All right, let's move on to the next one. So we want to know, is there enough information to prove the triangle ABC is congruent to DEC? So look at the markings. Looks like we have an angle and an angle, a side and a side, an included side, an angle and an angle. So I would say yes, that triangle ABC is congruent to triangle DEC by angle, side, angle. All right, again, you could say the third angle theorem, that this angle A is congruent to this angle D. There's no other information that would allow us to prove that any of the sides are congruent, okay? But you could mark those two angles congruent. All right, let's move on to the next one. For this next one, you may want to redraw the triangles so they're not overlapping. So let's first trace over the triangles we're supposed to be focusing on. J, K, L, and then close it back up. So from J to K, from K to L, and then back up from L to J. Try and draw a straight line. All right, and the other triangle is M, L, K. So it's this triangle here. All right, so if you wanted to redraw them so that they were not overlapping, so we have J, K, L. And then we have M, L, K. We have angle M congruent to angle J. We have this side KL is part of both triangles. So the reflexive property tells me that KL is congruent to KL. And then I also know that this side right along here, JL has to be equal to, that is congruent to that. I'm sorry, we don't necessarily know that. Let's back up. All right, we do know this reflexive piece right here. Okay, so based on the markings, this marking here is congruent to that. I need to include that. I forgot to put that on my diagram. So based on the markings, I have a side, and a non-included angle. A side, and a non-included angle. So remember, an angle and two sides, if the angle is not included, whether it's ASS or SSA, that is not one of our theorems or postulates, okay? Please don't write any curse words on your paper. If you do, you know that that's an example of a problem that you may not be able to prove the triangle's congruent, unless maybe there's other things you can mark, okay? So there's not enough information in that one. All right, let's move on to the next problem. So for this next one, I have that angle S is congruent to angle V. I have that angle T is congruent to angle W, and that side RS is congruent to side VU. So I have a side and two angles. It's a non-included side. Two angles and a non-included side. So yes, triangle RST is congruent to triangle UVW by angle, side. All right, let's look at the next problem. So for 5 and 6, it says Decide whether you can use the given information to prove that triangle LMN is congruent to triangle PQR. I would suggest drawing two triangles, and you could like try to make them look somewhat similar since they may be congruent, but again, they're just sketches. Label one LMN, and the other one, make sure you label it consistently, so PQR. And for the first problem, you're told that angle M is congruent to angle Q. You're told that angle N is congruent to angle R. And you're told that side NL is congruent to side RP. All right, so it says, decide whether you can use the given information to prove the triangles congruent. Explain your reasoning. So are the triangles congruent based on the markings? I have two angles and a non-included side, two angles and a non-included side. So I would say yes, that triangle LMN is congruent to triangle PQR by angle, angle, side. Two angles and a non-included side. All right. Now, if you wanted to use the third angle theorem, you technically could mark angle L congruent to angle P. And if you do that, you could actually now use angle, side, angle, angle, side, angle. All right. So you could use a different postulate, but you'd first have to tell me based on the third angle theorem that those two angles are congruent because that was not given. All right. Let's move on to problem 6. So for problem 6, again, I need to know the names of the triangles. I would sketch out a triangle and label it L, M, and N, and then try to sketch a similar looking triangle, and we'll label that P, Q, R. For number 6, you're told that angle L and angle R are congruent, angle M and angle Q are congruent, and LM is congruent to PQ. So I have two angles and an included side. I have two angles and a non-included side. So for this one, I would simply say not enough info just based on the markings. But let's go back and see if there's anything else that we could add. Third angle theorem allows me to say that this angle N is congruent to this angle P. Does that help? Well, now I could have angle, angle, side, all right? Or I could have angle, side, angle, right? Over here, it does look like I have angle, side, angle, but be careful. This angle doesn't match up with L or M, okay? Q does match up with M, but if you're gonna say angle, side, angle, then this angle needs to correspond to that, which they do, but this angle does not correspond to that. So angle, side, angle is not going to work for either. Okay, so just not enough information. Okay, all right, I think there's just one more problem. I want to do the proof, so let's just move on to the proof, and then we'll be done for this lesson. Okay, so we're going to not do all these practice problems. These are here. If you want to come back through and do some practice problems, you can always jump onto a 12th period Google Meet with me if you need some extra practice on this stuff. All right, so let's see. Let me get my statements and reasons set up. Statements. I need to write smaller. Sorry, I'm going to run out of room. It's not a super long proof or anything, but statements, reasons. Okay, so a few things to note. Remember, you're going to write down your given first and think about what does that allow you to conclude? What does that allow you to state in your proof? Take note you're given parallel lines. So as soon as you're given parallel lines, in your head, you should be thinking about alternate interior, alternate exterior, corresponding, same side interior, all those angle relationships. Okay, that's what we need to look for here. Also, when looking at your diagram, don't forget to look for vertical angles. Don't forget to look for the reflexive piece. Don't forget to look for linear pairs, right? Things that you can look at a diagram and mark and justify them, right? Without even being given the information, but just by looking at the diagram. Those are things you might want to include in your proof. And then finally, the last thing to note is if you're trying to prove that two triangles are congruent, your final statement is going to include, your final reason is going to include either side angle side as a justification, side side side, HL, angle side angle, or angle angle side, right? If we're trying to prove that two triangles are congruent, these are the things that we use to prove that the two triangles are congruent. If you're going to use side angle side, side side side, angle side angle, or angle angle side, you need those 3 stars and HL as well. You should be still using the 3 stars before you state the triangle congruency. All right, so you're given that PQ is congruent to TQ, that's given. You're also given that PS runs parallel to RS. So let's start with the first piece of given. If these lines are parallel, what angles are congruent? Angle P is congruent to angle T, their alternate interior, and angle S is also congruent to angle R. Those are alternate interior. So I'm going to write both of those down, that angle P is congruent to angle T, and angle S is congruent to angle R. And your justification is parallel lines imply alternate interior angles congruent. So notice I have 2 congruency statements about angles and 1 congruency statement about sides. At this point, you have your 3 stars. Look to see if you have enough markings to state that the triangles are congruent. All right, so you have an angle, and a non-included side, an angle, sorry, I should have started here, an angle, and a non-included side. So I know that triangle PSQ is congruent to triangle TRQ by angle, side. Now, is that the only way to do the proof? No. All right, let me back up for just a second. I did not use my vertical angles in this proof, right? I didn't mark it. I didn't include it when I was writing my justifications. I did not use the vertical angles. However, oops, I want to make that black so it matched. Oh, come on. Black, okay, put an arc there. If I use my vertical angles, okay, you can say that angle, name it with 3 letters, PQS is congruent to angle TQR. If you state the vertical angles are congruent, then you could use angle side angle as your justification instead of angle side. So you have options. It just depends on what information you provide in your proof, okay? All right, guys, that is it for lesson, whatever number this was, 5.6, I believe it was. I'll see you back here for the next lesson. Bye.